Okay. Everybody, can everyone hear me now? Sorry, we had some technical difficulties. All right, you hear me in Switzerland? That's awesome. Great. All right, well, we'll go ahead and get started, make up a little bit of time. I appreciate everybody attending and jumping on this. Here, you in New Orleans in Germany, fantastic. All right, so basically what we're going to do is, this is the first session of a 4-session series webinar on Dramix steel fiber reinforced concrete. So I get to be the guinea pig of the team and go with session number 1. And what we're going to do today is we're going to give an introduction to steel fiber reinforced concrete. First, we're going to talk a little bit about the history of fiber reinforced concrete. Some of you may be very familiar with it. Some of you may never heard of it, right? And then we're going to go through kind of the different types of fiber reinforced concrete in the market. And then we're going to kind of go into general aspects and benefits of steel fiber reinforced concrete, because at Beckert, that is what our business is. And then at the end, we'll kind of go through some pretty pictures there. And then we can answer questions at the very end. So make sure that you type those in the chat, and at the end we can answer them one by one. So just to give you a little bit of background on myself, I am the Southeast Sales Manager for Beckert, the Dramix Steel Fibers. I've been with Beckert for almost 4 years now. Prior to that, I was a practicing structural engineer. And I see that I've got some previous colleagues on the call. So hello, guys. And so we'll go ahead and get started. All right. Next slide. So first, introduction to fiber reinforced concrete. So if you're joining the call, you're in the construction industry. You know concrete. And right from day one, we know, what is concrete good at? It's good at compression. What it is not good at? It is not good with tension, right? So concrete is naturally brittle and has a low tensile strength and low ductility. So when subject to tensile stresses, it's going to crack or fail, right? In the industry, we don't like cracks. We don't like concrete failures. So we're all familiar with how we resolve that, right? So the principle of concrete reinforcement. So in order to change this, you added more ductile material. So mesh, rebar, and fibers are added as reinforcement to make up for where concrete lacks. So we're very familiar with this, right? It's going to increase load bearing capacity, flexural capacity, and then limit the crack widths. So little brief history. So we meet a lot of people. A lot of people go, well, steel fiber or fiber reinforced concrete's a new idea. Well, in fact, it's an old idea, right? The Romans actually used it. So they would either use hay or horsetail hair. So use that with combination of concrete, and then you have this nice composite material, reinforced concrete. So in the U.S., the oldest house is a house with sun-baked adobe that's reinforced with straw from 1840. Then move up to the 1800s. Fiber reinforced concrete was first patented in 1874, and the first steel fiber application is airfield in World War I. So this is a brief history. There's a lot of details, but we're kind of just briefly going through it. So in the 1800s, asbestos fibers were used. And we all know how that kind of turned out and found the health issues in the 1960s. So it really moved to glass and steel and synthetic fibers. So in the 1965, synthetic fibers were becoming a component of construction materials. The first steel fiber reinforcement was patented in the 1960s. And then Beckert, with our Dramix steel fibers, we introduced the first hooked-in steel fiber, and that was 1970. I left it off the slide. So Then the first U.S. steel fiber reinforced concrete is a truck weigh station in near Ashland, Ohio, and that was 1971. So even here in the States, steel fiber reinforced concrete has been around a long time and has been very, very successful. But from that initial stage to now, really the technology has really advanced, so you get optimal performance. So ACI 544 talks about fiber reinforced concrete. The main fiber reinforced concrete they talk about there is steel, synthetic, fiberglass, and natural steel fibers. So we get, well, aren't fiber reinforced concrete, isn't it all the same? Aren't the fibers, they do the same thing, you know, here, they do that. Well, in fact, no, they don't. Each fiber has a different capacity and performance that you need to utilize. So we'll kind of go through what are typical fibers and what they're used for here in the States. So in industrial and commercial applications are what we deal with mostly. So per ACI 360, you have one that very common is steel fiber reinforced concrete, is what we'll really kind of focus on during this presentation. And then you have synthetic fiber reinforced concrete. So synthetic is broken down into typically you would see a micro synthetic and a macro synthetic, if you've heard those words. On the steel side, you have a type 1 and a type 2. So the Dramix steel fibers, our steel fibers, fall under the type 1 steel fibers, and we'll kind of talk about the difference here in a second. So are they used for everything? So we're going to look at the main steel or fiber reinforced concrete segmentation. So on the non-structural, for crack control, microsynthetics are typically used in that when the concrete is setting and curing to prevent cracking. Right, but after the concrete cracks, then microsynthetics, post-crack kind of flexural and crack control are used. But you get up all the way to the top there in structural and true rebar replacement, the steel fibers are able to perform that as well. So our steel fibers, they're on the top, crack control and flexural performance. So we'll get into, now we're going to kind of dive into type 1 and type 2 steel fibers. So type 1, which Dramix steel fibers are cold drawn wire. So you see tensile strengths about 150 KSI to 334 KSI typically. So the type 1 steel fibers can provide both crack control and flexural performance. And with those, you tend to see moderate dosage rates. That's fiber or pounds per cubic yard, right? So also, since you have the flexural, you can sometimes reduce slab thickness and without losing load capacity. So they're typically engineered solutions and can be kind of more cost effective. The type 2 are cut sheet steel fibers. Tend to be wavy. There's different types, but the tensile strength's 87 to 94 KSI. Typically, not always, but they're used for crack control only. And you tend to see higher dosage rates. And the slabs, say for a slab on grade, they're typically designed as plain concrete with the fibers as crack control. So sometimes you can't thin the slab. You may have lost less cost-effective designs with that. All right, so we're going to get a little more into steel fiber reinforced concrete. We're going to go into the benefits, why you should use it on your projects, right? So just like we've said, steel fibers, they're engineered to replace secondary and primary rebar and mesh in concrete. So as we travel around, we meet with a lot of people and they say, okay, yeah, secondary reinforcement, which means kind of temperature and shrinkage reinforcement. Sure, fibers, that's what you do, but you can't replace rebar. And you know, we talk to them, educate them that yes, you absolutely can. Not all structural applications, but because of the flexural, the post-crack flexural behavior, we can, on a lot of projects and applications, replace all of the rebar or mesh, right? And so, like we were talking about, it's been a proven technology for 60 years. It's well established all over the world, and here in the States as well. So with the benefits, you get increased toughness of the slab, as you can imagine. You get a post-crack flexural strength instead of brittle plain concrete. Energy absorption, which is very important in underground situations, right? You get increased shear resistance, impact resistance, fatigue resistance, resistance to chipping and spalling, and then overall increased durability of your concrete projects. So where are steel fibers used? Where are Dramix steel fibers used? Well, crack control situations. So slab on grounds, slab on metal decking, industrial floors, heavy industrial floors, structural applications, precast, tunneling, right? All these demanding structural elements that need high-performing reinforcement can use steel fibers. Basically what we say, if there is reinforcement in it, we're going to add some value to your project. All right, so we're going to focus more on the type 1 steel fibers and then the benefits. So the benefits to the overall product that the owners will have, and then the benefits as the upfront cost to the contractor, right? Because upfront costs are a big deal in the US. Also, you want it to last a long time. You want to give your owners the best performance that you can. So why would you even join this call, right? It can kind of come down to this slide right here, where you get optimal load bearing capacity. So in the industrial slabs that we work on, the loads are getting heavier. The owners want future flexibility, right? The racks may change, or robots, might change and develop. So you want to make sure that your slabs, you don't have to rip it out, can withstand all that loading, right? Optimal crack control. No one wants cracks in their slab. So with steel fibers, you're able to provide crack control. High fatigue resistance for long-term performance, and then high impact resistance as well. But with all of these, I'm not as good of a salesman as I should be, so I can't say that all these benefits and it's going to be a premium. Nope, a lot of the times, and most times, we're able to save the contractor and the owner cost. So it's a cost-effective solution. We'll kind of go into why that is, right? So one is labor intensive, right? So with fiber reinforced concrete, the fibers are added to the truck. So it's basically a concrete mix. So the reinforcement is added into the concrete. So when you place it, it's like placing plain concrete. Whereas mesh and rebar, you've got to transport it. You have to have site conditions that can able to handle it. On an elevated deck, you have to, raise it up. You have to crane up the rebar, and then you've got to tie it all together. What if you have issues with rain? Your job site is flooded. You got to tear that out, clean it. So with that, you can reduce a lot of the labor savings by going to a steel fiber reinforced slab. So like we were talking about, you can imagine it requires less man hours to put it in place. So there's significant schedule savings. A lot of times we can see up to 30% schedule savings by switching to steel fiber reinforced concrete. The industry as a whole is going to safer job conditions. A project that I was on in Texas, we were up on the deck and it was 103 degrees, and the rod busters are carrying all the rebar. They're tripping over the double mat of steel, and to get rid of all that and just place the concrete is a big deal, right? It is a lot safer for your workers. They're not tripping over all the rebar and things like that. So here's a owner, right? So that money saving and very fast. So if you have a project that you're behind schedule and it has started, you might propose steel fiber reinforced concrete, because you can make up that time a lot of the times and offer really a superior product. So let's talk about kind of when you transition to the owner, what do they get with that? Well, with fiber reinforced concrete, you have full depth reinforcement. So wherever a stress is located, right, in any plane, you have a fiber there to resist it, to hold those crack widths tight. Whereas with reinforced concrete, plain concrete, if you have concrete cover, right, that it can spall. It's just unreinforced. There's sections of it that are unreinforced, as opposed to steel fiber reinforced concrete. So a lot of times we can thin the slab. We've talked about it because you have a stronger slab section because of that three-dimensional reinforcement throughout the thickness. Whereas traditional reinforcement and no reinforcement at all, right, there you have to provide a cover, and you don't get as strong a slab as you would with a steel fiber reinforced concrete. So, you know, when you're comparing with mesh, we always get a little laugh in the office. You know, I don't know, this probably doesn't happen on your projects, but we've seen it. You know, mesh tends to, unless it's chaired properly, it tends to lay on the bottom, and it's really not doing its job. Excuse me. So in industrial applications, say a rack, industrial slab, rack supported, or a storage facility, right? You have post-installed anchors, and it's an issue when you have a top mat of rebar or a mat of rebar in the middle. A lot of times a contractor has to coordinate those where the locations are, and that just costs a lot of headache, and it costs a lot of time. Well, if you get rid of all of the reinforcement, right, you have ease of drilling in and installing those post-installed anchors. So it is a great advantage to the contractor in those type of applications. So another thing that we tell owners is that as your costs go on, right, so you have a forklift going over the saw cut joints, they're going to start to deteriorate. And on a traditionally reinforced slab, you have that concrete cover again, right? So that forklift goes back and forth hundreds of times a day, it's going to deteriorate. So then you're going to have to go back and patch it, or, you know, if it gets too severe, replace the slab. Whereas with steel fibers, you can see in this fantastic graphic that the steel fibers are right there at the edge, right at the saw cut. And I will say, and we'll get to this in the other sessions, is that we are looking to, and we see the future in the U.S. and North America is getting rid of saw cuts. So extending the joint, construction joints, and eliminating saw cuts. So we eliminate that headache altogether. Another question we get is, well, steel fibers, they're probably not good for exterior applications or corrosive environments, right? And in fact, they're fantastic for it. It is increased with Dramix steel fibers, right? So basically, if you have rebar and mesh and it starts to rust, then it's going to expand. It's going to propagate along there. Those stresses increase and it spalls the concrete. Well, when you spall the concrete, you've basically lost a good percentage of your capacity, your load bearing capacity. And then over time, it's just going to severely deteriorate. Well, steel fibers, they're discontinuous, right? So if they happen to be exposed at the top and they corrode, they're very small diameters, so they can't exert the same stresses that rebar or mesh can. So your concrete's not going to spall. And maybe there's another fiber right next to it that touches it and corrodes. But you don't lose that load-bearing capacity over time that you would with rebar. So matter of fact, it is a great solution for corrosive environments and exterior pavements. So that is a little history. We've gone through kind of the basics, the benefits of it. Next would be just kind of practical aspects. How is it loaded into the truck? What changes for the contractor? You know, if we're going to propose it, you know, what's going to change for them? What the construction sequence? So we'll kind of talk through it. So steel fibers, like another admixture, are added to the concrete. They can be dosed at the batch plant, or they can be dosed on the job site. A lot of times we prefer to be dosed at the batch plant. The ready mix can kind of work with the mix design to get a great mix with steel fibers. But either way, it is definitely possible. So it really depends on the project. So our steel fibers come in 44-pound or 20 kg bags, and they can be cut at the top. And then a lot of times people use conveyor belts. You slowly dump it on the conveyor belt, and it dumps it into the back of the truck, or it can be dumped with the aggregate. One thing that we always recommend is the fibers should never be the first component in the mix. It shouldn't be an empty truck you place the fibers in there, because they can tend to ball the way that they're set up. So last in the mix or added with aggregate, and you should have no issues. So then you mix at full mixing speed, 70 revolutions, about 5 minutes. So usually if you're one side of the job site and you're going to place it, it's not holding up any time. If you're at the batch plant to the job site, it tends to be more than 5 minutes. So that's not an issue. And that makes sure the fibers are fully distributed through the truck. So another one is, well, we can't pump it. Well, we pump a lot of projects with no issues. If we kind of have the saying, if it can be pumped without steel fibers, the mix, it can be pumped with steel fibers. We do recommend with our fibers that you have at least a 4-inch diameter hose. So basically point to ACI 304 for pumpable concrete. To prevent balling, which can cause havoc in the pumps with steel fibers, is we glue our steel fibers, and that gets rid of the issue of potential balling. Also, by adding it last in the mix, you don't want to add it first in the mix. It dissolves the glue, and the fibers can ball. So with the glued fibers that we offer, that prevents the balling there. So construction methods basically remain the same. You can tell the contractor it's similar to placing plain concrete. You can tailgate the concrete. You don't have to pump it, right? That saves a lot of time. The contract or the concrete truck pulls right up, tailgates, and the finishers can finish it. Vibration and leveling, right? With these big, large industrial projects, a laser screed is used. If you have a layer of rebar or a double mat of rebar, it's very challenging to use a laser screed. And the laser screed helps to get those floor flatness, floor level requirements that you need. Also, you don't have to pull up the mesh or the rebar behind it, so it's basically the reinforcement is right there in the concrete. Pull up, place it, and then you can finish it. Power trowel, it is the same. You're going to use the same procedures that you would with regular concrete. And then curing, same with regular concrete. It's you can wet curing blankets, curing compounds. They're all compatible with our steel fibers. All right, cutting of saw cutting slabs. I think that the majority of slabs that we see in the U.S. are saw cut. So really the only thing that changes there with the steel fiber reinforced concrete, and ACI 360 talks about it, is when using a soft cut or an early entry saw, is to cut a little deeper, right? You have a steel fiber slab that is very strong because of the steel fibers. Well, you want to make sure that you weaken that slab where you want it to be. right? Otherwise, you may get a cracking just off the saw cut. So you want to make sure you cut them deep, and you want to make sure that you cut them with the right time, just like any other slab. If you cut them too late, the slab can crack because of temperature and shrinkage. We typically follow, the spacing of the saw cuts, ACI requirements. But like I said, and we're going to talk to you about in the next one of the next sessions, are jointless floors, where we're getting rid of saw cuts altogether. All right, so basically that's the construction side of it. Now we get a look at some of the pretty pictures and different applications where our steel fibers have been used and are really gaining momentum. So jointless floors, that's where you're eliminating saw cuts. So Keurig and Dr. Pepper in South Carolina, 800,000 square feet went last year. It's a beautiful, beautiful slab. And on that, it's 130-foot joint spacing between the construction joints. We also, it's worth mentioning that it's robot ready. So we get owners that say, well, steel fibers, we can't, use that. We can't use robots on it. It may mess with the system. But it's used all the time with steel fiber reinforced concrete without negative effects. Here's another one that went just this year in Kansas City. That one went 140 feet joint spacing with that. And that's with steel fibers alone. Here's a fun one that I visited this summer, but wasn't able to go inside. But this is the National Air and Space Museum in Virginia and DC there. So the really interesting and fun thing about this is that it's a seamless floor. So it's steel fibers plus mesh. With that, you're eliminating joints altogether. So basically you have a construction joint limit is how much you can place at one time. So if you walk this floor, there are no joints on this floor. So we do probably a dozen or more of storage facilities in the U.S. each year. They're very popular. This one happens to be a slab on piles, so a structural application. It's a 3-story storage facility in Chattanooga, Tennessee that was just performed this year. And then down the bottom, this extra space storage, 3-story. It was completed last year. It's in Midtown Atlanta, but it is a matte slab foundation that eliminates all the rebar. And then also our steel fibers are used in the slab on metal decking. So going back to corrosion, right? This is an exterior pavement in Cherryville, North Carolina. So North Carolina, if you don't know, it can get really hot and it can get really cold. So with that, with the freeze thaw and really hot temperatures, this is a 30-year-old slab, and you ask any owner, your project, your property, would you like it to look like this in 30 years? And this sees pretty frequent and heavy loading. So, like I said, steel fibers are a great exterior pavement application. So here's a fun one. This is up in Washington State. So our steel fibers were used in coupling beams. There was too much rebar. They couldn't install it all. And so our steel fibers were used to supplement that, to reduce it because of the ductility that it provides. You've seen this one, CCTV tower in China. It's fun. Our steel fibers were used for that in combination with reinforcement in the columns. So there's an example of projects that we've done and typically done. So I think it surprises a lot of people in the industry that we're just not a vendor, that we're not going to just sell you steel fibers and move on, right? We're there with you every step of the way. We want to educate you, develop it. we want to offer design support. Like I said, I was a structural engineer, so going through to the design, we also have in-house software that we can make available to you if need be. But then we don't leave it there, right? We're able to provide on-site support to make sure that projects go well. We want to team up with contractors and engineers and ready mix that give a quality product. So we want to make sure that we're with you the whole way, that we have repeat business. So our hashtag at Beckert is better together. We really want to team up with quality people in the industry. So that's it. I appreciate your attention, taking the time out. I know everybody's swamped. We can go ahead and start answering the questions in the chat if there are any. But if you would like more information, please reach out to me, email me, call me, and we can discuss further. And be sure to join the next session, which is December 3rd, and we'll discuss technical aspects and design approach with our steel fibers. So going through the chats.
So Josh, I saw one question that was about the normal dosage rate. You were talking about the dosage comparison between type 1 and type 2. So like generally speaking, what would you say is a normal or moderate dosage rate?
Yeah, so I would say our typical that we see on industrial slabs, we're 20 to we're in the 20s or 30 pounds per cubic yard. We do see as low as say 13.5 when we're just crack control. But I would say it ranges 20 to 30. When we get into structural applications or jointless projects, those dosage rates maybe upper 30s up into the 50s. So it can really vary on the different applications, but I would say day to day, you're 20, 30 pounds per cubic yard. The cost, if you use steel fibers, so it depends really on the project, and it depends on the location. But like I said earlier on, if you have reinforcement on your projects, we have a solution that will be cost effective. Whereas it's in material or labor time savings, it's going to be a cost effective solution. Any more last minute questions? All right, everyone. Well, be sure to join the next one where it's a more of a technical discussion. Mine was just kind of an overview. I really appreciate you guys joining it, and have a great rest of your week. Take care. Also, you can email questions if you come up with it. Just want to reminder you there, joshua.lee@beckert.com. Feel free to ask any questions that you may have.